In this graph, we'll begin with the assumption that tastes are rational, that is to say, complete and transitive. To say that tastes are complete simply means that individuals are able to compare different bundles and tell us which they prefer, or whether they are indifferent between the two. To say that tastes are transitive implies that if bundle A is preferred to bundle B, and B is preferred to bundle C, then it must be the case that A is preferred to bundle C. We'll then ask what we can tell about a consumer's tastes over different bundles if we add the assumption of monotonicity, the assumption that more is better, or more is at least as good. We'll assume that there are two goods, pants and shirts, and we begin with the bundle A. Bundle A contains 8 shirts and 4 pants. Bundle B, on the other hand, has 2 shirts and 8 pants. So far, the monotonicity assumption doesn't tell us very much. Bundle B has more pants but fewer shirts, so we can't apply an assumption that says more is better because bundle B has more of one good but less of the other. Bundle C contains 5 shirts and 6 pants, and thus has more pants and fewer shirts than bundle A, and fewer pants and more shirts than bundle B. We therefore still don't have a bundle that has more of everything relative to another bundle, or more of one good and the same of another good. Thus, the more is better assumption still doesn't tell us anything about how a consumer would rank these 3 bundles. But now consider bundle E, which contains 6 shirts and 7 pants. Bundle E contains more of everything relative to bundle C, more shirts and more pants. Thus, the more is better assumption implies that E must be preferred to C. But E does not have more of everything relative to A or B, and therefore we cannot use the monotonicity assumption to rank bundle E relative to A or B. All we can say is that E must be preferred to C by a consumer whose tastes satisfy monotonicity. Bundle D contains 5 shirts and 4 pants. Therefore it contains the same number of shirts as bundle C, but fewer pants. In cases where we have 2 bundles where one contains more of one good and the same of the other good, we'll say that we can still apply the more is better assumption, only now our interpretation will be that we can conclude that C is at least as good as D. In most cases, C will be better than D, but we'll have some types of tastes that satisfy our monotonicity assumption, where C is just as good as D. Similarly, bundle A has more shirts and the same number of pants relative to bundle D, so we can conclude, based on the monotonicity assumption, that bundle A is at least as good as bundle D. And bundle E contains more of everything relative to bundle D, so bundle E must be preferred to bundle D if the monotonicity assumption holds. Bundle B, however, contains fewer shirts and more pants, and therefore the monotonicity assumption does not help us in ranking bundles B and D. We have explored how much we can say about how a consumer might rank these bundles if the consumer's tastes satisfy the monotonicity assumption. We could also ask whether we can say anything more about how the consumer ranks these bundles if we also assume that the consumer's tastes are convex, or if the consumer's tastes satisfy the averages are better than extremes assumption. This assumption says that if we know that the consumer is indifferent between 2 bundles, we also know that any average of these bundles will be at least as good as the more extreme bundles. In this case, we don't yet know whether the consumer is indifferent between any of the bundles, so without knowing anything more, the convexity assumption doesn't help us very much. Suppose, however, that we know that the consumer is indifferent between bundles A and B. In that case, we know that any average between those 2 bundles is at least as good as A and B. Bundle C is in fact an average of A and B. If you take the number of shirts in A and B, 8 plus 2, and divide by 2, you get 5, which is how many shirts there are in bundle C. Similarly, if you take the number of pants in A and B, you get 4 plus 8, which gives 12, divided by 2 is 6, which is the number of pants in bundle C. You can also tell that bundle C is an average of bundles A and B because it lies on a line that connects A and B in the graph. If all this holds, we can now also say something about how E is ranked relative to B and A. Because if C is at least as good as A and B, and E is preferred to C because of monotonicity, then transitivity tells us that E must be preferred to A and B.